Hello. Let's talk briefly about how to read the output of GeoGebra in terms of making decisions about tests of significance. So, as a reminder, when you're making a decision about a test of significance, we're asking, is there evidence to support the alternative hypothesis or insufficient evidence to support the alternative hypothesis? And the p-value is telling you how likely you are to have gathered a sample with this sample mean or proportion, like randomly, assuming the null hypothesis was true. You compare the p-value to the level of significance. The p-value is what GeoGebra computes. The level of significance is given to you in the problem. If your probability, your p-value, is less than alpha, so if you have a small probability, that's evidence to support the alternative hypothesis. If your probability, your p-value, is larger than the level of significance, you have a large probability, that is insufficient evidence to support the alternative hypothesis. So here's an output for GeoGebra. We're not going to look at what the full question statement is. Watch other videos for that. In terms of reading what it's all saying and whatnot, the first part, all of this section right here, all of this part, this is all like the problem statement, what's given to you initially. In this case, we can see that this is some kind of measurement of means. The null hypothesis is that whatever they're measuring is 21.7, and the alternative hypothesis is that the true population mean is less than 21.7. This is the data that they gathered, so their sample had a mean of 21.6 with a standard deviation of 1.72, and they discovered that they had 40 individuals in their sample, and so now we come down to reading the result. In terms of making a decision using a p-value, all we care about is this last line. This p right here, this is the probability that we are interested in. This is what we will use to make our decision about whether to accept or fail to reject. In other words, or make our decision whether or not there's evidence to support the alternative hypothesis or insufficient evidence to support the alternative hypothesis. So this question didn't give me a significance, so let's just suppose, let's choose a level of significance of 0.05. Doesn't really matter because this is a very high probability. It's unlikely. There's not really any level of significance for which we would choose to say we have evidence to support the alternative hypothesis. But say if the problem, so when I say choose, let's say that the problem told us that alpha is equal to 0.5. So the problem tells us to use a significance level of 0.05. Then I would compare the two p-values. So I would say, oh, in this case, comparing my p-value to alpha, I would note that p is about 0.3565. Alpha is 0.05. 0.3565 is definitely larger than alpha. So because the p-value is larger than alpha, we would say that we have, in this case, insufficient evidence to support the alternative. In this case, it's going to be to support the claim that mu, the population proportion, is less than 21.7, which I got from this statement up here. Generally speaking, in an actual problem, instead of saying the claim that mu is less than 21.7, you should actually use the situation that the problem describes. We just don't know that here. Just to give you an example of what it looks like if we're working with proportions instead of means, or what the output looks like. Again, the first part here, all of these sections over here are just stuff that's given to you in the problem. What we're interested in is the results. So this is telling us the number of successes. This repeats what it is. This is the test statistic. In terms of making decisions based on p-values, what I'm interested in is this last row again. That p is the p-value. So that is this, the probability of how likely we would have gathered this particular sample with this particular proportion. So in this case, the probability that we would have gathered a sample that had 123 successes out of 358 people, if it was really true that the true population proportion was 29%. So again, to make our decision, I want to compare my p-value to the level of significance. The level of significance would be given to you in the problem. So let's just choose, again, this would be told to us, but let's just suppose that the level of significance is 0.05 again. In this case then, comparing my p-value to my level of significance, I'd have my p-value is about 0.2548. Comparing that to my level of significance, 0.02548 is less than 0.05. And so because of that, because p is less than alpha, we're saying we have a small probability. Small probability means there's evidence that something is going on. It is evidence for the alternative. In this case, it seems that the alternative is that the true proportion is in fact not 29%. So just to summarize real quick, when you were reading the output of GeoGebra, trying to make decisions about the p-value, you're looking at the very last line, and this is what you enter. You can kind of ignore all the rest of it. It is the last line labeled as p. That is the p-value that we are interested in. That is the probability that we would get our sample result if the hypothesis, the null hypothesis, were true. If the probability is less than the significance level, you have evidence to support the alternative. If the probability is greater than the significance level, you have insufficient evidence. The probability, the p-value, is calculated by GeoGebra. The significance level is told to you in the problem. Hope this helps.